One. Today we will solve May-June 2023 QP42, that is theory paper. Let's start with first question. A list of oxides A to H is shown. So here they have listed many oxides, basic and amphoteric, acidic, and they have asked us questions based on that. Answer the following questions about the oxides A to H. Each letter may be used once, more than once, or not at all. State which of the oxides A to H is responsible for acid rain. So, acid rain, we have two oxides, nitrogen oxide and sulfur oxide. So, nitrogen oxide is not given, but we have sulfur oxide here. So, the answer will be D. Has a giant covalent structure. We have three giant covalent structures, that is diamond, graphite, and silicon oxide. And the oxide here that we have is C. Next is a reducing agent in blast furnace. So in blast furnace, we use carbon monoxide, that is our reducing agent. We have that here, and the answer is H. Next is the main constituent of bauxite. So the constituent of bauxite is mainly aluminium oxide, and we have that here, that is B. Is the main impurity in iron ore. So we have impurity in iron ore, that is silicon oxide. Again it is repeated, so we'll write C here. Can be reduced by heating with copper. So uh, we have, after copper in the reactivity series, we have silver. So we have silver oxide here, okay, that can be reduced, or silver can be displaced when it is reacted with copper. So we'll write G here. Question 2. Fluorine, chlorine and bromine are in group 7 of periodic table. State the name given to group 7 elements. So we know group 7 is named as halogens. B. Explain why group 7 elements have similar chemical properties. So the group number tells us about the number of electrons present in the outer shell. Okay, as all these elements are in the same group, they have same they have same number of electrons present in their outer shell, and hence they share similar chemical properties. So they have same number of outer shell electron. Next, C. Complete table 2.1 to show the color and state at room temperature and pressure of some group 7 elements. So, fluorine and chlorine, they both are gas. That is how you can remember. Bromine is the only liquid, and after that, like iodine and acetylene are solid. Okay, next we have is chlorine. So, color of chlorine is pale yellow green, and bromine is reddish brown in color. Next, D. Bromine has two naturally occurring isotopes, bromine 79 and bromine 81. State the term given to numbers 79 and 81 in this isotopes of bromine. So this is mass number of bromine. Next, complete table 2.2 to show the number of protons, neutrons and electrons in the atom and ion of bromine as shown. These are very easy questions, and this should be done accurately. You should score full marks, so you should never go wrong in such type of questions. So first is bromine 79, which is atom. Okay, we have to find atomic number of bromine using periodic table, and it is 35. So how should we find neutrons? So neutrons will be 79 minus 35, which will give us 44, and electrons will be same as protons, so it will be 35. And in case of bromine, which is here a negative ion, so atomic number remains same, that is the number of protons will be same, that is 35. Okay, the mass number changes here, so 81 minus 35 will give us 46, and you can see that there is a charge here, that is minus 1 charge, meaning bromine has accepted an electron, so the electron will be 36. Next, table 2.3 shows the relative abundance of two naturally occurring isotopes of bromine. So here they have given us the mass and the relative abundance. The formula is very simple. Okay, mass into relative abundance plus mass into relative abundance. So 79 into 55 plus 81 into 45 upon 100. Okay, so here you will get 79.9 mass. This formula is again very simple. It is for 2 marks. If you write the answer only, that is 79.9, you will get only 1 mark. You have to show the working as well. Next is E. Chlorine displaces bromine from aqueous potassium bromide but does not displace fluorine from aqueous sodium fluoride. Write the symbol equation for the reaction between chlorine and aqueous potassium bromide. We are supposed to write a symbol equation, okay, between chlorine and potassium bromide. So we will write Cl2 plus Kbr, which is gonna form KCl plus Br2. We will have to balance. We have two bromine here and one bromine in the reactant side. So we'll write 2 in front of Kbr. Hence we'll have to write 2 in front of KCl also. Next, state why chlorine does not displace fluorine from aqueous sodium fluoride. Here we should know the trend of group 7 reactivity, that is reactivity decreases as we go down the group. Okay, so fluorine is the most reactive element in halogens, and hence because it is more reactive, chlorine cannot displace fluorine. So chlorine is less reactive than fluorine. F. Aqueous silver nitrate is a colorless solution containing Ag plus ions. Describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. Now, this you have to think from the point of view of ions, okay, identification of ions. Silver nitrate is a test for halogens specifically, okay. So, if you add silver nitrate and aqueous sodium chloride, it is gonna give you white precipitate. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium chloride. You are supposed to write the ionic equation and not the complete chemical equation between the reaction of silver nitrate and aqueous sodium chloride. Okay. So only ions will be involved here. So we already know the charge of Ag plus ions, which is Ag plus only. Okay, meaning we require only one chlorine ion. So it will be Cl minus, which will give us AgCl. Now we have to write the state symbols. So here you see we have used aqueous silver nitrate, meaning it will be AQ for Ag plus. Similarly, we have used aqueous sodium chloride. Chlorine comes from sodium chloride, so that is also in aqueous state. And we have written here we have got a white precipitate, meaning the AgCl that is formed is solid, a precipitate. Next, question 3. Over 200 million tons of sulfuric acid are manufactured every year. A. State the name of process used to manufacture sulfuric acid. So we know the industrial process which is used to manufacture sulfuric acid is known as contact process. B. Part of the manufacture of sulfuric acid involves converting sulfur dioxide to sulfur trioxide. Describe two methods by which sulfur dioxide is obtained. So, first of all, we can directly burn the sulfur in the air, okay, and second is roasting sulfur ores, okay, which is basically again when we are roasting it, okay, so from air oxygen is again gonna combine with sulfur to form sulfur dioxide or sulfur trioxide. Okay, so first is burning sulfur or roasting sulfide ores. Next, the conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. They have also given us the equation. State two features of an equilibrium. So these are the this is the constant answer. Okay, whenever they ask you features of equilibrium, you have to write the same answer or the characteristics of equilibrium. So rate of forward reaction is equal to rate of backward reaction, and second is concentration of reactant and product stay constant. Next, state the typical conditions and name of the catalyst used in conversion of sulfur dioxide to sulfur trioxide. So you have to always read the reaction conditions of Haber's process and contact process. Many a times as it is, these questions are asked. Okay, so the temperature for both the processes is same, which is 450 degrees Celsius. Okay, and in case of pressure, you have to always see which units are given, whether it is atmospheric pressure or whether it is kPa, that is kilopascals. According to that, the values will change. So if it is in kilopascal, so it is 200 kilopascal. If it is given in atmospheric pressure, it is 2 atm. If none of the units are given, you can write any value you want. Okay, but you have to always keep in mind, just see which unit is given. Next is catalyst. So we use vanadium 5 oxide, vanadium pentoxide. Next, complete table 3.1 to show the effect, if any, when the following changes are applied to conversion of sulfur dioxide to sulfur trioxide. The forward reaction is exothermic. It is clearly mentioned. Okay, you have to use increases, decreases is no change. Only these words should be used. Now, effect on rate of forward reaction, that is the speed or the rate of reaction is asked here. Okay, and in the second column they have asked about the concentration of SO3 at equilibrium. Both these things are totally different. One is the speed of the reaction and second is the concentration of the given, that is sulfur trioxide. First one, that is temperature. If the temperature is decreased, rate of reaction is definitely going to decrease, which is already done for us. What happens to the concentration of SO2? Now the temperature is decreased here and the forward reaction is exothermic, which does not require energy because already the forward reaction is exothermic in nature. Okay, it is releasing energy already. So the concentration of SO3 is gonna increase here. Next, pressure increases. If the pressure will increase, definitely the rate of reaction will increase because the particles will come much closer together. Now, whenever we talk about pressure in terms of equilibrium, we have to first check the number of moles on both the sides. So here we have 2 SO2 and there is nothing in front of oxygen, meaning we consider 1. So 2 plus 1 is 3 moles in the reactant side, and we have only one product, that is SO3, which is again 2 moles here. So we will write 2 moles of product. Okay, whenever the pressure is increased, the equilibrium shifts towards the side where there are few number of moles of gas. Okay, so here the equilibrium will shift towards the right hand side, that is the RHS, and hence the concentration of SO3 is going to increase. More of SO3 will be made or produced. So it will be increased here. Next, in case of catalyst, now catalyst has effect on rate of reaction. Okay, so if there is no catalyst, definitely the rate of reaction will decrease, but in case of equilibrium, there is no change. Catalyst does not help to increase the concentration or decrease the concentration, or there is no change in the shift of the equilibrium. Okay, catalyst only and only helps to increase the rate of reaction. Next, explain in terms of collision theory why reducing the temperature decreases the rate of forward reaction. Okay, now many a times we have an habit that always they ask about increase in temperature. Okay, but we have to read the question properly. They are asking about decreasing the temperature and hence why the rate of reaction decreases. So it's very simple. If the temperature is decreased, the particles will have less of kinetic energy. Okay, so kinetic energy of particle will decrease. Now if the kinetic energy decreases, definitely the collision between the particles is also gonna decrease. Okay, so frequent collisions between particles will decrease. And the third point, there will be lesser particles which will have energy greater than activation energy. Okay, so very less particles will undergo reaction or will take part in the reaction. So few particles have energy greater than activation energy. Next, sulfuric acid contains SO4 minus ions. The oxidation number of oxygen atoms in SO4 minus ions is minus 2. Determine the oxidation number of sulfur atoms in SO4 minus ions. Show your working. Now here, if you see, oxidation number of oxygen is clearly mentioned, which is minus 2. Okay, and the charge on this sulfate ion is minus 2. Okay, so we are supposed to find oxidation number of sulfur. So how will we find? So we have SO4 2 minus. Okay, oxidation of sulfur we have to find, so it will be X plus we have 4 oxygen atoms, so 4 into oxidation number of oxygen, which is minus 2, and because it is a compound ion, it is having a charge on it, it is not neutral, so instead of writing 0 we will write the charge which SO4 2 minus is carrying. Okay, so sulfate ions are carrying a minus 2 charge. Now, x minus 4 2s is 8 is equal to minus 2. This minus 8 will go here. So, x is equal to minus 2 plus 8, which is gonna give me plus 6. Okay. So, oxidation number of sulfur we get here is plus 6. Next, question 4. Solid sodium hydroxide is a base which dissolves to form an aqueous solution. State what is meant by the term base. Bases are defined as proton acceptor. B. State the term given to a base which dissolves to form an aqueous solution, which is known as alkali. State the color of thymolphthalin in sodium hydroxide. Thymolphthalin turns blue in color in bases or alkali, so it will be blue in case of sodium hydroxide. D. Complete the word equation for the reaction of sodium hydroxide with ammonium chloride. So when sodium hydroxide reacts with ammonium chloride, we will get a salt. that is sodium chloride. Okay, then we will get ammonia and we will get water. So this is a typical reaction of bases or alkalis when they react with ammonium salts. We get ammonia as a product. At lab scale, we can do this. E. Some metal oxides react with sodium hydroxide. State the term given to metal oxide which react with bases such as NaOH. So we have acidic oxides that can react with bases or alkalis, okay, and we have one more type of oxide that reacts with both acids and acids and bases, that is known as amphoteric oxides. Second, name a metal oxide which reacts with sodium hydroxide. We have two examples of amphoteric oxide, either aluminium or zinc. You can write any one. So we will write aluminium oxide. F. Ethanoic acid is a weak acid. Complete the dot and cross diagram of a molecule of ethanoic acid. So if you see the diagram, they have already given us the representation for whom we have to use dot and for whom we have to use cross. Okay. So here, first of all, we'll complete the dot and cross between carbon and hydrogen. So there are 4 electrons present in the outer shell of carbon. Okay. Here we have been given 3 hydrogens. So we'll give or share one electron of carbon here. So dot, dot and dot. Okay. So if carbon shares 1 electron, even hydrogen needs to share one electron. We'll do that. Okay. Carbon and carbon. So 3 electrons are shared, only 1 electron is remaining. So here carbon will also share only 1 electron. And we will have this another cross of the other carbon. Okay. Next is the second part of carbon and oxygen. So here again carbon is having 4 electron in its outer shell. Okay. So here this carbon is gonna share 2 electrons with this oxygen. So dot of oxygen and a cross, again a dot of oxygen and a cross. Okay. And 4 electrons in the outer shell of oxygen. Okay. Here, so here if you see for this carbon atom, 2 electrons are shared with this oxygen, 1 electron is shared with the other carbon atom. So 3 are already shared, only 1 electron is remaining to share. So again we'll share with this oxygen here. Okay. And this oxygen is also bonded with hydrogen. So again it will be a dot of oxygen and a cross and 4 electrons on the outer shell of oxygen. That is how we complete the dot and cross structure. Next, suggest the pH of dilute ethanoic acid. So ethanoic acid is actually a weak acid. Okay, and also it is dilute here. So we can write any number, we can say around or between 3 to 6. Okay. So we'll write 4 here. Okay. Complete the symbolic equation to show the dissociation of ethanoic acid. So as I said, ethanoic acid is a weak acid. Okay. So it will be a partial dissociation. That's why we will have a reversible reaction here. So it is CH3 COO minus and H plus. Next, write the ionic equation for the reaction when an acid neutralizes a soluble base. Soluble base meaning it's an alkali. Okay, so the ion responsible for acid is H plus and ion responsible for an alkali is OH minus. When they combine, it forms water, H2O. If here they would have asked you for a base, so for base we have O2 minus. Okay, so the ionic equation for that would become 2H plus O2 minus, giving us H2O. So you have to read what they have given. G. In a titration, 25.0 centimeter cube of 0.0800 moles per dm cube aqueous potassium hydroxide is neutralized by 20.0 centimeter cube of dilute sulfuric acid. Equation is also given to you. Calculate the concentration of sulfuric acid in gram per dm cube using the following steps. So first of all, we have to calculate the number of moles of KOH. We already have the values, that is centimeter cube is volume, mole per dm cube is concentration. So we'll use N is equal to C into V upon 1000. So we'll write 0.0800 into 25 upon 1000, which will give us 0.002 or 2 into 10 raised to minus 3. Determine the number of moles of sulfuric acid which react with KOH. Now here they have only given us volume of sulfuric acid. They have not given us anything else. So we will take a ratio of KOH is to sulfuric acid. For that we will use the chemical equation given. So H2SO4 is to KOH, which is a, for KOH it is 2 and for H2SO4 it is 1. There is no stoichiometric coefficient written in front of H2SO4. So it is a 1 is to 2 ratio. For H2SO4 we have to find the number of moles, so it is X. For KOH we have just found, which is 0.002. When we cross multiply them, it is 0.002 divided by 2. So it is 0.001. Calculate the concentration of sulfuric acid in mole per dm cube. Now we have moles of sulfuric acid and volume of sulfuric acid is already given to us, which is 20.0 centimeter cube. We will just rearrange this formula to find concentration. So it will be C is equal to N into 1000 upon V, which is equal to 0.001 into 1000 upon volume of sulfuric acid, that is 20. So the answer we get here is 0.05. Okay, and finally we have to find the concentration of sulfuric acid in gram per dm cube. For this you will have to multiply the mr, molar mass of sulfuric acid, with the concentration in mole per dm cube. Okay, so first of all we'll have to find mr of sulfuric acid here, which is 2 hydrogens into its mass, which is 1, plus atomic mass of sulfur, which is 32, plus 4 into mass of oxygen, which is 16, which is giving me a total of 98. Okay, so 98 into 0.05. So this gives me answer, which is around 4.9 gram per dm cube. If you solve mole question stepwise, you will score full marks here. Here, writing down the MR of sulfuric acid is important because this question is for 5 marks. So 1 mark is for finding the molar mass of sulfuric acid. Okay. Next, question number 5. Propane and propene both react with chlorine. When a molecule of propane reacts with chlorine in presence of ultraviolet light, one atom of hydrogen is replaced by one atom of chlorine. It is clearly given here that one atom of hydrogen is replaced by one atom of chlorine. State the term given to reaction in which one atom in an alkane is replaced by another. This is known as substitution reaction. State the purpose of ultraviolet light in this reaction. So ultraviolet light is providing activation energy. Activation energy to start the reaction. State the term given to any reaction which require ultraviolet light. So wherever light is required, that is known as photochemical reaction. Photon meaning light. Next, write the symbolic equation for the reaction between propane and chlorine. So you can use general formula of alkane to find the molecular formula of propane, which is C3H8, that reacts with chlorine, which is Cl2, and one atom of hydrogen is replaced by one atom of chlorine. Okay, so what it will become? C3H7, one atom is replaced, that is hydrogen. So from C3H8 it becomes C3H7, and one atom of chlorine we will add here, plus the hydrogen that is being removed will combine with another atom of chlorine to form HCl. Next, B. A molecule of propene C3H6, formula is also given to you, is unsaturated and will react with chlorine at room temperature. State why propene is an unsaturated molecule. Now, from the name itself, ENE, that is propene, is an alkene. And why it is unsaturated? Because it is having a carbon carbon double bond, or because it has a carbon carbon bond which is not a single bond. Okay, yeah. Give the structural formula of the product of this reaction. So if I react propene with chlorine, okay, so what will be my structural formula? So in that case, I will write the structure. So first I will draw propene here. I'll draw displayed one so that you understand. So we have 1, 2 and 3 chlorine carbons with one double bond, and remaining will be my hydrogens here. If I react it with chlorine, the chlorine atoms will get attached where there is a carbon carbon double bond, across the carbon carbon double bond. Okay, so this structure will look something like this: 1, 2 and 3. The double bond would get converted to single bond because the chlorine atoms will bond where I was having my double carbon carbon double bond. So here it will come, and the hydrogens remain same. So I am supposed to write structural formula. So I will write it stepwise here. So it is, I'll write it stepwise. So it is CH3, then bond, then I have CH, Cl, then again a bond, and I have CH2Cl. So this is what I will have to write here, which is CH3, CHCl, CH2Cl. Next, C. Propene undergoes addition reactions with steam. There are two possible products, A and B. Draw the displayed formula and name each product of the displayed formula A and displayed formula B. Now, whenever propene or alkene reacts with steam, it forms an alcohol. Okay. Now, here there are two possibilities we are going to get. First, the alcohol, the functional group of alcohol attach at the first carbon atom, or it attached to the second carbon atom. So there are two possibilities, that is propan 1 all and propan 2 all. So the displayed formula of the first product will be, we have prop meaning 3 carbon atoms. So it is 1, 2 and 3. As I said, the functional group can attach on first carbon atom. So we'll write that OH, and remaining will complete with hydrogens. So it is named as propan 1 all. And in the second case, the OH functional group can move to second carbon atom. At the second, we have OH here, and remaining of my hydrogens I'll satisfy the valency of carbon. So the name becomes propan to all. Yeah. Next, question number 6. Carboxylic acids can be converted to esters. Name the ester formed when butanoic acid, formula is also given to us, reacts with ethanol. While naming the ester, we always name the alcohol first. The alcohol we have used here is ethanol, so it will get converted to ethyl. The carboxylic acid used is butanoic acid. Okay, so we'll write ethyl first. From butanoic, you have to write it till butan, which is butan. Esters are named as O8, so we'll just write O8E. So the name becomes ethyl butanoate. B. Identify other product formed in this reaction. Whenever carboxylic acid and alcohols react to form esters, there is one more product formed which is water. Deduce the empirical formula of the ester formed. Okay, so we have to find the empirical formula here actually of the ester which is being formed. For that, we will have to first form the structure of ester. So, in this case, OH from carboxylic acid and hydrogen from the ethanol is removed. Okay, so I'll just copy the structure as it is for both of them here. So, which is my CH3, CH2, CH2CO, and I'll flip this. Okay, so it is O, the ethanol part I will flip. So, O, CH2, CH3. Now I will have to find my molecular formula first, that is how many number of carbon, hydrogen and oxygen atoms I have. So for that I have total 1, 2, 3, 4, 5 and 6. 6 carbon, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen atoms and I have 2 oxygen atoms, O2. This is my molecular formula. Okay, this is my molecular formula. Now I have to convert it into my empirical formula. So I will simplify it. Okay, so I have C6H12O2, which can be converted to C3H6O. So my empirical formula I have is C3H6O. Next, PET, polyester, part of the structure of PET is shown. Circle one repeat unit of this polymer. So the one repeat unit will include one carboxylic acid monomer, one alcohol monomer and one linkage of ester, which we can consider this one like this. Next, draw the structures of the monomers which make up PET. Draw the functional groups using displayed formulae. Now here we know that it is a condensation polymerization, okay, and we require two monomers. The two monomers you can identify here is one is your this part and another is your oxygen part. The one is shaded, the one is unshaded. Okay, so we have identified as it as carboxylic acid and the another one is alcohol. So we'll draw. First is my carboxylic acid, so C double bond O, OH. On the other hand also C double bond O, OH. And the other I have is the unshaded one, which is alcohol, H. State the type of polymerization used in making PET. So here we have used condensation polymerization. Differentiating between condensation and addition polymerization is easy because for condensation we require two monomers and for addition reaction we have a monomer with a carbon-carbon double bond. Okay, so this was the last question. Hope you have understood whatever we have solved in this paper.